My name is Albert Abraham Michelson, and our experiment is to find the existence of ether, which is a substance that is believed to be filling an empty space. Originally, we were trying to find evidence to prove that ether actually existed, but our theory was that light should be able to move through ether at different speeds depending on the relative moment throughout the space. So it didn't matter how fast it's going, that light can just move through ether. We were just trying to figure out what is ether, so that's what we're trying to do now. Originally, I'd done the experiment by myself at first in 1881, and I kind of let it fall off the radar because I was so focused on something else. But after accepting this position at the Case of Applied Sciences in Cleveland, I met Edward Morley, where we began to collaborate ideas and bounce off each other, and that's how we came together and figured out that we actually did the real experiments during April and July in 1887. So it's a long time, guys. That's a good question right there. What other significant events happened during this time? To be honest with you, I was so focused on my stuff that I thought that my stuff was the most important. But only thing I could really think of is the Nikolaus Tesla. He was doing X-rays. Yeah, he was doing X-rays in the beginning of the trials of X-rays, and it's so crazy how that's like it's really fundamental into today's world. Because X-rays are pretty big. As I said it before, Edward Morley was he helped me with it. He was a professor of chemistry at the time. What school did he go to? He was at the Western Reserve College. Yeah, that was some pretty good time. My role into the experiment was that I designed a device known as the inframeter, which is sent the beam from the single source of the light through a half silver mirror that was split into two beams traveling at the right angle to one of another. After it splits the splinter, the beam travel out the ends of the arms, where they are reflected back to the middle by the small mirrors. Then they're combined from the far side of the splinter in an eyepiece, producing a pattern of constructive and deconstructive interference based off the length of the arms. And any slight change of the amount of time in the beam's spin in transit will be observed as a shift in the position of the interference. So that was a pretty big thing that I created. It took me a long time. What impact did I have on the physics community? To be honest with you, I really thought the thing had failed because we had found no proof. We believed that it just didn't work, so we found out that ether didn't exist. But our results of the whole experiment was that light didn't travel during different speeds. It was like it didn't, but most of the scientific community, I think, believe they disagree with our assumption. But later on, Einstein's theory of relativity was able to account for my results. According to Einstein, there was no such thing as ether, and light has a constant speed no matter what frame of reference that you measure it from. But I think our experiment helped further on the questions of what is ether. So I feel like that would really truly impacted it. It didn't do what I wanted to do, but I mean, put my name out there, so that's why he contacted me. And I just want to say thank you for the opportunity for having me and stuff. And see you later.